Hi, in this video we're going to talk about tangent lines. This is one of the big deal foundational ideas of calculus. So in the last video we were looking at a function, and so we had graph of a function. We were looking at y equals x squared, and we talked about slopes of secant lines. So we had a couple points on the curve and we looked at a slope of the line that connects those 2 points, and so we looked at slopes of secant lines. And then one of the questions that we talked about is to think a little bit about what would happen if we would take that second point and let that get closer and closer and closer to that first point. So that's essentially what we're going to be looking at here, is what would happen when I take the second point on my secant line and let that second point get closer and closer and closer to the first point, and really consider that in terms of a limit. So we have a big deal important definition to memorize. You see where it says important definition to memorize? That's really true. You need to know this. Okay, so the definition says we define the slope of a curve at x equals c to be this statement here. So this is m for slope. And then down below it explains what the tan means, but m, tan, is defined to be. And then what we have over here on the other side here is a limit. And so we want to think a little bit about what this is. So on the numerator here I have 2 outputs. So these are outputs at one point, x equals c, and at another point at x equals c plus h. So those are outputs at x equals c and x equals c plus h. So we've got points. One of the points would have an input of c and an output of f of c. And then the second point, which would be have an x coordinate that's a little bit different. So it's different by this h amount. And then we've got the output of that. Okay, so what we have here are 2 points, and the numerator we've got the change in output, the f of c plus h, that's our second y value, minus the first y value for the first point there, so the change in y on the numerator. And then on the denominator it looks like what we just have is an h, but if we think about what would really happen if I calculate the slope of the line between these 2 points, I would have second y coordinate minus first y coordinate over second x coordinate minus first x coordinate, and then you might notice those c's will cancel, and so you're just left with that h that we have on the denominator on this definition. So the key idea here is that this definition, the right hand side of this definition, this is really just slope. This is slope. Change in y over change in x, and then the 2 points are at x equals c and x equals c plus h. And then the part about the limit says we're going to let that h, which would be the distance between those 2 points, approach 0. So this is really just formalizing that idea of letting that second point get closer and closer to the first point. All right, so you want to be able to memorize and write down that definition, including the LIM out front. That'll be important, and be able to write that down perfectly and correctly every time. So practice that until you can do it. Okay, and then the definition, the other part of the definition here at the end says that the line through the point at x equals c with that slope is called the tangent line to the function at that point, x equals c. Okay, so we're going to look at some graphs of that to kind of see what's happening with that. So I'm going to click over to some graphs. Okay, so what we're looking at here is a graph of a function, and it doesn't really matter exactly what the function is, but this one's a parabola, and I've got a secant line. This green line is a secant line through 2 points on that curve. And what I'm going to do is change some things over on the left side of the screen. I don't really want you to pay attention too much to that right now. I want you to focus on what's happening with the graph. But when I let that second point get closer and closer and closer to that first point, we see that what we get we get that second line getting closer and closer and closer to the first point, and eventually when h approaches 0 all the way to 0, I get that that second point ends up on top of the first point, and I get this purple line. So this purple line is that tangent line that we were talking about when I let that second point get closer and closer and closer to the first point. Okay, on the left side of the screen though, over here, what I do have is I have an h slider, and I dragged that slider so that h approached 0. So eventually I got h to be 0 there. And I did that on the right side of the graph, where my second point was on the right side of the graph. But we know that for a limit, if I'm considering the limit as h approaches 0 of something, I need to let h be both bigger than 0 and smaller than 0. So I left the first point at the same place there. It's purple on the graph. And I now have a picture of what would be going on if h is negative. That second point this time would be left of the first point. And again, I'm going to drag, 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 so that I'm going to let h approach 0. So the distance between those 2 points is getting smaller and smaller and smaller. And what I'm really interested in, the definition we looked at there, was the slope of that line. And so what I got here is a tangent line, and that tangent line to that graph is the tangent line to that curve at that particular point. Okay, so we kind of looked at what it means to take a limit of the slope of a secant line and let that second point get closer and closer to the first point, and so we could kind of see how that tangent line was being created. The other thing that you should be able to do with these curves, though, is to kind of visualize what a tangent line would look like at different points on the curve. So I'm going to actually just leave this as a tangent line, so it's that purple line, but I'm going to drag around a little bit the point, and so we can kind of think about what exactly is happening when I'm looking at tangent lines at different points on the curve. So over here on the left side of this parabola, if you look at those lines, you see that they have a negative slope over there. And one important thing is that if I zoom in really, really close to the graph, near that point, you can see that it's almost indistinguishable where the line and the curve are, that the line is a very, very good approximation for the curve at that point. And so that's one of the big deal ideas of calculus 2, is that we can use these lines to approximate what's happening with curves at points. And so if I drag that around, you can kind of see that at all these different points, I've got a line that's a very, very good approximation for the curve. And when I zoom in and zoom in and zoom in, see that the line and the curve are very, very close to each other. And the more you zoom in, the more they look alike. So that's what we're talking about when we're talking about tangent lines. We're talking about a line that best approximates a curve at a point. They have the same slope. That definition that was important to memorize. So we're going to stop here, and then in the next video I'll do some examples of actually calculating slopes of tangent lines for different functions.